In this video, I will guide you through several examples which slowly build up to the final method. Hopefully, this will help you understand and remember the process of how to solve a quadratic equation by completing the square. X plus 2 squared equals 49. Take the square root of both sides. Remembering the square root of 49 is plus or minus 7. We subtract 2 from both sides. This means x is either equal to negative 2 plus 7, that's x is equal to 5, or x is equal to negative 2 minus 7, that's x is equal to negative 9. X minus 1 all squared equals 20. This is very similar to our previous example, but when we take the square root of both sides, we get the square root of 20, which is a third on the right hand side. Now we want to simplify this, so this becomes plus or minus the square root of 2 root 5. We add 1 to both sides, we get 1 plus or minus 2 root 5. You can leave your answer like that, but bear in mind that that means that x has got two answers, 1 plus 2 root 5, or x is equal to 1 minus 2 root 5. But it's okay to leave your answer in that form. Okay, this example might look different to the first two, but it is in fact just the same if you spot that x squared plus 2x plus 1 is in fact a perfect square. Very handy to be able to spot perfect squares. Alright, so now we do the same thing that we did before, and we get x is equal to minus 1 plus or minus the square root of 5. Okay, x squared plus 2x is equal to 4. You might say, well, finally, something that doesn't have a perfect square in it. Well, we can in fact make this a perfect square just by adding 1 to both sides. 4 and 1 becomes 5, and lo and behold, this becomes the same as our previous example, and we've already solved that, so I won't do it again. But the crucial step is we can make this into a perfect square, and then we can solve it using our technique already learnt. X squared plus 2x minus 4 equals 0. You might look at this and go, yay, I can factorize it, but you won't have much luck. So, is there another method? Well, if we add 4 to both sides, we're going to get the equation we've just solved. And now, the next step, if we add 1 to both sides, we end up with a perfect square on the left-hand side, and we've already solved this. I won't do it again. But x is equal to minus 1 plus or minus the square root of 5. Our next example is x squared minus 5x plus 3 equals 0. Now we could try to factorize this to solve it, but we won't have much luck in this case. So let's try to transform this equation so one side becomes a perfect square, and then we'll be able to solve it. So, to do this, what we're going to do is rewrite that constant, the plus 3. We're going to move it to the other side of the equation by adding negative 3 to both sides. And notice I'm just going to leave a space here because what we're going to do is we're going to look for a number that we're going to add to the left-hand side and the right-hand side. We're going to add, though, so that the left-hand side of the equation becomes a perfect square. Alright, now the question is, what number do we need to add? Well, we're going to need to remember our expansion of a perfect square. So let's look at x plus a all squared. That is going to become x squared plus 2ax plus a squared. Right? Now if we have an x squared term and a 2a plus x term already, and we want to find out what the a squared term is, we can look at this term here and look at this coefficient. Okay, and if we half this, it's going to give us a. Okay, then square the result and square it. Okay, that is going to give us a squared, which is what we write in. So we look at minus 5. We say, what is half of minus 5? Half of minus 5 is minus 5 on 2. Alright, and we have to square this to make the left-hand side a perfect square. Now, of course, if we add negative 5 over 2 all squared to the left-hand side, we have to add it to the right-hand side as well. Alright, so let's tidy this up. Now, the left-hand side becomes x minus 5 on 2 all squared, and the right hand side becomes minus 3 plus 25 on 4. Now we're just going to point out, why did we get the minus 5 on 2 here? If we look at our expansion again of x plus a, we have the a here, and this is 2a, so we're going to half of the 2a gives us a. Alright, so that's how we got this term here. Alright, so let's now tidy this equation up. X minus 5 on 2 is equal to the square root of the right hand side. Now I'm going to swap these terms around and write them in fractions. X is equal to 5 on 2 plus or minus the square root of 13 on 2. Okay, x is equal to 5 plus or minus the square root of 13 all over 2. And that's our answer. Our final equation is 3x squared minus 4x minus 1 equals 0. The most obvious difference here is this is a non-monic trinomial. So we need to divide by 3 to make it monic. That's the first step when completing the square. The next thing to do is to move the constant to the right hand side. Now we need to complete the square on the left hand side. Look at the coefficient of x and halve it and square it and add it on. We're going to add on half of negative 4 on 3 all squared. Now the left hand side we rewrite as a perfect square. Now taking the square root of both sides, we get, adding 2/3 to both sides will give us, and of course we can now combine the fractions to give us our final answer, 2 plus or minus root 7 all over 3. This is a quick summary of how to solve quadratics by completing the square. Firstly, make the quadratic monic. Next, move the constant to the right hand side. Then halve the coefficient of x, square it and add this to both sides of the equation. Factorize the left hand side, it'll be a perfect square, and clean up the right hand side. Take the square root of both sides. Remember to take the plus or minus on the right hand side of the square root. Finally, simplify.